Welcome back to another Daishinfinity video. In this video, we're going to prove the sum of quadratics, which states that the sum where k goes from 1 to n of k to k squared, so the sum of squared numbers, is equal to n times n plus 1 times 2n plus 1 divided by 6. So I'm going to prove this using induction. So we know, or we suppose, that the sum where k goes from 1 to n of k squared is equal to n times n plus 1 times 2n plus 1 all divided by 6. Now let's suppose this is true. So we will start by using n is let n not equal 1, and let's say we will start from 1 since k is from 1 and n is always bigger or equal to k. So since k is 1, n can always start with 1. So if we start with 1, we have k is equal to 1 to 1 of k squared, which is just actually 1 squared, so it's 1. But if we would use the right-hand side of the equation, it would mean we have 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6, which will equal 1 times 2 plus 1 is 3 divided by 6, which is 6 divided by 6, which is also 1. So we have just proven that it works for n not being equal to 1. Now we cannot prove it for every n using this kind of way. We actually have a very smart way of proving this. It is called induction. So proof by induction. It states that if we have any sum where k goes from any n naught to any n of some ak, and that is equal to some property, then we can obviously also imply that it works for n plus 1. So if we have a natural number n, since the natural numbers are going on forever, it will also work for any n plus 1, which will also mean that the right-hand side will be like mn for n and mn plus 1 for n plus 1. Okay, so let's suppose that the sum k is equal to 1 to n of k squared is equal to n times n plus 1 times 2n plus 1 divided by 6. And we assume that it works for n plus 1. So let's just plug in the n plus 1. K goes from 1 to n plus 1 of k squared. By definition, you just plug in the n plus 1 in this equation. So n plus 1 times n plus 1 plus 1, so n plus 2. And 2 times n plus 1 is 2 times n times plus 2 plus 1, so it's 2n plus 3, all divided by 6. So this is what we assume. Now we can assume this, but we have to prove it. So this is the proof that is going to come now. Since we know it works for n, we are trying to prove it for n plus 1. So the sum as k goes from 1 to n plus 1 of k squared is equal to the sum as k goes from 1 to n of k squared plus the sum as k goes from n plus 1 to n plus 1 of k squared, which is actually by the supposed theorem or supposed equation is actually equal to n times n plus 1 times 2n plus 1, since we suppose this is true, plus the n plus 1th square number. Now, since we want to put them together, I would like to multiply and divide both by 6 of the n plus 1 square, so that we can put the fractions together. Then we have n times n plus 1 times 2n plus 1, all divided by 6, plus 6n plus 1 square, all divided by 6. This will actually equal n times n plus 1 times 2n plus 1 plus 6 times n plus 1 square, all divided by 6. What would this mean? We see that we have an n plus 1 and an n plus 1 on both summation parts, so we can take them out of both of them. So we have n plus 1 times n times 2n plus 1 plus 6 times n plus 1, since we have 2 times of the n plus 1 divided by 6. Now we can actually calculate the middle part, and we are going to say that we want to have an n plus 1 times 2n squared plus n plus 6n plus 6 divided by 6. This would equal n plus 1 times 2n squared plus 7n plus 6, all divided by 6. Now, from the supposed equation, we have k is equal to 1 to n plus 1 of k squared of n plus 1 times n plus 2 times 2n plus 3 divided by 6. This is what we suppose. We would like to go there. If this is supposed, we would like to go from this equation onto this equation. So since this is the same and the 6 is the same, we would actually have to prove that this quadratic formula is actually equal to these two parentheses multiplied by another. So let's just look at the quadratic formula. We have n plus 1 times 2n squared plus 7n plus 6, all divided by 6. Now, if you ask yourself, how can we put them into two parentheses? It's a difficult thing to do since we have a coefficient of 2 in front of the n squared. But it's not that difficult if you see a pattern that if you separate the 7n into two parts, let's say 3n and 4n, then we can actually figure out a pattern of how we can put them together. So this would actually be equal to n plus 1. And I'm doing this on purpose since 7n can be written as 3n plus 4n plus 6. The reason why I'm doing this is since we have a 2 and a 3, and 4 is 2 times 2, and 6 is 2 times 3. So if we plug in the 2 outside, then we have 2 times 2n plus 3. And since we have an n too much over here, we can plug in an n outside and would have something that is similar to this. We would have n plus 1 times n times 2n plus 3 plus 2 times n plus 3. Yeah, I hope this is correct. I think I made a mistake. 2 times 2n is 4n, and 3 is 6. Okay, so this is correct now. And now we have n times something plus 2 times the same something, so we can plug in that outside of the parentheses. So we have n plus 1 times 2n plus 3 times n plus 2 divided by 6, which is actually just same as saying a times b is b times a. So I'm just going to rearrange the parentheses and say that we have n plus 1 times n plus 2 times 2n plus 3 all divided by 6. And this is actually equal to the sum as k goes from 1 to n plus 1 of k squared, which was supposed in the first place, and we have just proven that this is actually true. So I hope you liked and enjoyed this video. Please like and subscribe and follow. And if you have any questions, write them in the comments, and I hope you enjoyed this video. And we're going to see us in the next Daishinfinity video. See ya.